Good morning, good afternoon, and good lunchtime to all of you, depending on where you are located in the United States. This is Alex Handy, Senior Editor of the Software Development Times, here with you today for this webinar from Sencha entitled Visualizing Complex Data Within Your EXT JavaScript Apps Using D3. It's so fun to pronounce all of the acronyms we have in this industry. So, without further ado, I would like to hand it over to Gautam Agrawal. And Gautam he leads product management at Sencha. He is responsible for guiding new product strategies and roadmap initiatives across the Sencha product portfolio. Additionally, Gautam works with strategic partners to establish and develop new market opportunities. Prior to joining Sencha, he held various product and engineering positions at organizations developing SaaS and business intelligence applications. Gautam also holds a PhD and a master's degree from the State University of New York at Buffalo, otherwise known as SUNY Buffalo. So without further ado, I will hand it over to Gautam.
Thank you, Alex, for the introduction. So let's begin. The amount of digital data in the world is growing at an exponential rate, doubling about every 2 years, and essentially changing the world that we live in today. Today, the rate at which we are generating data is outpacing our ability to analyze it, as said by Professor Patrick Wolf from Big Data Institute. The data stored as a result of our regular day-to-day work is just incomprehensible. And some of it is obvious things that enterprises do with this data, that is to try and understand their customers, the markets, leads, etc. But then there is that not so obvious information that is piling up, such as usage logs, largely ignored from the perspective of who the user is, or what they're trying to do, or where they are, and things like that happen in our software systems. With the lack of understanding of the information that this data contains, we still, for the most part, continue to try asking questions and getting answers from our data. Someone asks a question and puts in an IT request and IT folks dig through this data and return the answers in form of tables or graphs. But do we really know all the questions? So let me share some mind-blowing stats with you around the data that we're generating today. According to IBM, every day we are generating 2.5 quintillion bytes of data. So much so that about 90% of the data in the world today has been created in just the last 2 years. And it's amazing to know that when we sent astronauts to the moon in 1969, the amount of data that was available to scientists and engineers was an infinitesimally small fraction of what we have on our personal computers today. We are almost living in a digital universe which is growing at 40% year over year. And by 2020, our digital knowledge is expected to grow to about 44 zettabytes, up from 4.4 zettabytes. And just for the sake of understanding the scale of this information, imagine 1 gigabyte would be approximately 960 minutes of music, and 1 zettabyte would be about 2 billion minutes of music. We would need about 20 lives spanning over 100 years just to listen to that amount of music. So today we are drowning in data, and by some estimates that the 99.5% of the data in the world today hasn't even been looked at. So how do we solve this problem? Data visualization is the key. It's a powerful way to simplify the complexity in our data and present it in formats that are comprehensible, intuitive, and insightful. With the explosion of big data, visualizing data is becoming ever more important. In terms of bridging the gap between our ability to understand this data and the insight that this data carries. Visualization turns data into information. So presenting data in pictorial or graphical format essentially enables decision makers to grasp difficult concepts or identify patterns that are otherwise not even possible to decipher from the data that we have. In context of business, there are really two broad level goals of data visualization. One is explanation and second is exploration. So when it comes to explanatory data visualization, we're basically seeking to tell a story to the viewer. There's typically a narrative which a person is trying to convey. The designer of the visual essentially starts by asking a question or two to the data. For example, how much sales did we do in last quarter, or is my sales trending upwards or downwards, and things like that. And the charts and graphs simply answer such questions. The viewer follows the visual clearly because the designer has brought out the answer in form of the story that the visualization is telling. And most visualization we come across in our day-to-day scenarios today fall into this explanatory category. In businesses, they appear in form of dashboards, presentations, charts and graphs in your marketing content, sales content. It's almost everywhere. On the other hand, the exploratory data visualization, it seeks to discover stories. It tries to find out what the data is telling. They're not really designer driven or the person who is creating that visual. It's rather viewer driven. The emphasis is not on a single story or important story, but it's on discovering many small stories that the data might be carrying or that the data might be telling. So the designer may not even be sure what story is in the data. And the aim of the designer is to present data in a way that invites viewers to notice obvious trends and discover patterns and gain surprising insights from that data. It simply gives a way to a number of ideas for the viewers to make something meaningful out of the data. Though not as popular, exploratory visualizations have been gaining prominence in recent years with the rise of big data. And the high volume of data and the varied data sets that have become common today can only be analyzed using these exploratory visual mining, data mining tools. So in summary, the explanatory data visualization, you're using visuals as an effective means to communicate the story you want to tell. Digging a little deeper into the explanatory data visualization, there are many things that people use in day-to-day data visualization. For instance, the use of tabular displays is fairly pervasive. It's not really visualization, but tables are still one of the more prominent ways to share data. Basically presenting data in rows and columns, but people, I mean, even though they're not visualization, people are still using tabular displays. And the core reason is that they're really in rush of sharing that data. They don't have enough time to create visualization out of it. If you're using tables to tell the story in your data, make sure you're showing only the relevant and a very limited number of columns and rows, and avoid scrolling, because very soon your user will be lost in terms of what information it contains. The other, or rather more prominent way to visualize explanatory data is charts and graphs. It's most widely used techniques purely because of their simplicity and how easy they are to comprehend. It's almost like we're all wired in our head to understand these charts and graphs pretty quickly and intuitively. But it's important to understand that these visuals, even the charts and graphs, can distort reality. So as an example, if you look at the chart on the right, at the first blush, it may seem like that the last column of the grand total is significantly bigger. Well, that's because it's the grand total across all categories, and such representations should be avoided. A grand total is not appropriate to display in this chart, because if you look at the rest of the data, you're trying to do a comparative across your categories, and it is distorting the rest of the categories in terms of the magnitude that is visible on this graph. And these are basically the quirks that needs to be ironed out when you're using charts and graphs. So if you're creating explanatory visualizations, Abella's chart suggestions could be a good set of guidelines in terms of what charts and graphs you should be using under what situations. These guidelines essentially categorize your explanatory visualizations into 4 categories of doing a comparative, or showing a distribution of your data, or or a composition in terms of pie charts, or identifying or displaying relationships. And as I mentioned before, in exploratory visualization, the visual designer already has a narrative. And if you already have a narrative, it's quite easy to figure out whether the narrative that you have falls under one of these categories. And so identifying the right chart based on your narrative could be made easy, in you would know by that sort of categorization whether you want to use a pie chart versus a bar graph or a scatter plot, because you have to look at your narrative and you have to identify whether you're trying to show distribution or composition or relationship or comparison. And these are just high-level guidelines in order to pick the right set of visualization, explanatory visualization, from what's available out there. Now let's talk about exploratory data visualization. Essentially, as I mentioned before, your goal is to not really explain things, but use data visualization as a tool to understand the story behind your data. Since you're exploring the story in your data, which may span hundreds of columns and thousands of rows, or sometimes even millions of rows, as sort of depicted pictorially in the table on the right, there are unknown relationships and patterns that are not obvious in this data. And most importantly, you don't have a narrative. You don't know what questions to ask. And the goal is that you want to explore one or more narrative inside of this data to identify those patterns visually. This is where D3 becomes very important. In last few years, we've seen that D3 has become one of the most rapidly adopted tools in the exploratory data visualization world. It's extremely powerful general purpose data visualization tool. Note that it's not a charting library per se, it's not a mapping library per se, although you can make charts and maps out of it, but it's basically a tool for displaying complex data in ways that regular charts and graphs don't do. And another important factor that one should note is D3 doesn't work on bad browsers, so which is it is only HTML5 compliant browsers that you can use this on. So if you're using legacy browsers such as IE 8 or 9, obviously this is not a solution for that. So what is D3? It's essentially a JavaScript library for producing dynamic and interactive data visualizations in your web browser. It makes use of the latest standards, JS-SVG, Scalable Vector Graphics, and HTML5 and CSS standards. And in contrast to charting solutions, D3 basically gives you a great deal of control over your visual results. So you're not bound by a specific visualization that is pre-created or a pre-canned visualization. you could really make all kinds of visualization simple to complex and explore your data in terms of the patterns it contains. So in context of ExtJS, if you think of these two broad level terms, explanatory data visualization and exploratory data visualization, we already provide a data package. If you're familiar with Sencha ExtJS, we have a charting package that contains column charts, bar, pie, line, scatter, and everything that you need in terms of taking your data in your application and presenting it visually and narrating or explaining your story that you know of. And the second piece that we are trying to we are adding to ExtJS is basically D3. Since D3 has already become so popular in the exploratory data visualization world, we are basically creating an adapter that will allow you to bring D3 into ExtJS apps and use D3 capabilities for exploratory data visualization. So some of the core principles that D3 that one should be aware of is that at its core, D3 is based on a coordinate system, which starts at the top left, and also paths that allow you to create highly customized polygons, unlike the regular charts and graphs, which are very, very specific and which don't really span like complexities that you see in the D3 land. The library also provides a selection of DOM nodes, which is much like your CSS selectors in your any HTML5 or JavaScript framework. And it also allows you to manipulate and use transitions, append nodes or remove nodes, or even interpolate attributes in the graphics that you're trying to create. But probably the most important concept in D3 in terms of enterprise data visualization is data binding and layouts, so that you can use a data set that you could draw from your backend systems in formats like JSON or CSV or arrays to create objects in form of elements and algorithms, reusable algorithms that basically create some pictures, and you'll see that in a moment what kind of layouts and algorithms are available. So, for instance, in this picture, it's a hierarchical layout that you could use on your hierarchical data structure. It basically uses a recursive spatial subdivision algorithm to display 3 nodes. Now, you can imagine if you have really complex data, for instance, you have everything for global 2000 companies in terms of what market capitalization is there, what growth is there, percentage of growth, and things like that. You could put all of that into a single visual and then start exploring as to which companies are doing better than others. And minded, the goal is to explore as opposed to asking a question to the data. Another one that you could look at is a tree map, which basically a tree which lays out in form of diagrams, and then you can go interact with these nodes and explore what is underneath them. A pack layout is an algorithm basically which represents another level of hierarchy where the size of each node is a circle that is associated with the quantitative dimension of each data in your hierarchical data set. And the enclosing circle basically shows some level of approximation of the cumulative size of those nodes. Something where it produces an sort of an adjacency diagram in a space filling variant, much like the node filling tree diagram. Another one is a bundled layout, which implements another hierarchical edge bundling algorithm, where you basically each link input is and a path is computed that travels through the tree up to the parent hierarchy, to the least common ancestor, and then back down to the destination, so that you can see what is connected to what at a high level, at a glance, as opposed to recursively traversing a tree. And similar layout is a chord layout, which produces a chord diagram at a much lower level of abstraction. So how have we integrated all this into ExtJS? Obviously, ExtJS is one of the most popular and comprehensive frameworks for building data-rich, data-centric applications, and we already have the charting package. But one of the core elements of ExtJS as a framework is what is the data package. We provide a data package inside the framework that carries all kinds of data, or tree data, or even regular store, regular flat data. And what we have done with this integration is created component level integrations wherein all these layouts and algorithms can feed off of those data package. Like you see in here, we've created a component X type D3 view Treemap, which essentially tells that layout that you can feed from the store, which is a tree store, or you can feed from a regular store. And what that does is, now when you're using D3 in your ExtJS application, you don't have to spend a whole lot of time in terms of parsing your data, or in terms of navigating the data that you want to bring into your ExtJS application, or for that matter, what might already be present in your grids and pivot grid and whatnot. Another example is what if you were to do some custom work. So we've also created ways for you to bring in custom visualizations that may be available as a part of D3, and give you means to bring in those custom visualizations as is, without having a component level integration. So for instance, if you want to bring in a visualization on the canvas itself, not necessarily associating it with a tree store or a regular store, you could do that as well. And the goal is to provide an adapter layer and a integration that helps you utilize the capability of D3 inside of ExtJS applications, as opposed to trying to do a one-to-one or 100% component level development for every visualization that is possible in D3 or that is available in D3. So we are looking at a number of layouts or algorithms that I was discussing before, and where it makes sense, we are doing component level integration, so that those complex visualizations can be automatically created by using just a D3 component, and also leaving certain things to you in terms of what other visualization you may want to create by providing examples in terms of how to bring custom visualizations in ExtJS. Another example here is a tree data. We basically created a view tree component, which again feeds off of a tree store, and in this case, it's basically doing a file system visualization where every node is representing a folder and the files therein, and you could interactively explore that if you need to. So this D3 adapter is coming to ExtJS pretty soon. We are targeting the early access and or beta available to be made available by end of this month. So one of the questions that I get asked, and we've been doing some roadshows and presentations in our customers and community, and one of the questions I get asked is, why are we doing this? And the simple answer to that is, as a mission, Sencha basically wants to provide everything that our developers need to rapidly build data-intensive cross-platform enterprise web application. And if you look at what we have so far in our offerings, we have grids and pivot grid and charting package that all are geared towards exploratory visualizations and big complex data-centric applications. But this D3 integration basically adds a layer of exploratory analysis, exploratory data visualization to our software that we provide. And that, we believe, adds a core capability in terms of working with big data application and complex data-centric applications. And it takes the Sencha application to a whole new level in doing exploratory analysis. What's the advantage of using Sencha when you're doing some of these things? Obviously, most of you are familiar that we are one of the most comprehensive frameworks with all kinds of UI components that is available. That are pre-integrated and tested, so you don't have to source in pieces of technology to build your application. More importantly, data intensive. Our goal is to focus on everything that you need for building data-intensive applications, so you can analyze, visualize, and interact with complex data from any source within your ExtJS applications. Another key differentiator is our single coding paradigm. So we use a JavaScript first approach, which is not to worry too much about DOM and CSS unless you need to. Everything that you want to do for your application or build in your application, you should be able to use JavaScript to create your application. That's our philosophy, and that's why we've created a JavaScript first taken the JavaScript first approach to build a comprehensive solution that we have. And then obviously the professional enterprise support that we provide with our training services and technical support teams that are globally present. Some of the key verticals that I want to share with our viewers that we operate in are financial services, automotive, media, entertainment, healthcare, networking, government, transportation. And the key theme there is that all these companies are riding on big data and they're sitting on a lot of data, and they're wanting to make sense of that data. So it's very important to have capabilities like exploratory data visualization using D3, and that's why we are making this move towards integrating with D3. A little about Sencha, for those of you who are not familiar with Sencha. We are a venture-backed startup founded in 2007. Redwood City is our headquarters, about over 100 employees, funded by Sequoia Capital, Icon Ventures, and Radar Partners. We've really put a lot of effort in building the Sencha framework, which is the most comprehensive framework that you'll find for building cross-platform, data-intensive, cross-browser applications. And we are in over 60% of the Fortune 100 companies building those kind of sophisticated applications. So if you are looking forward to build some of those kind of applications for the data that you might be sitting on, Sencha is obviously the right choice for you. So at this point, I'll turn it back to Alex for any questions that our viewers may have.
Sure. Thank you very much, Gautam. If you have questions out there, folks, please feel free to pop them into the question box, which you should be able to see there. I will be able to see them when Shauna makes me the organizer of this and I see the question box. In the meantime, we have a starter question here. What level of integration in
Alex, you're still there? I lost you.
Did you not? You can't hear me? Hello?
No. Yeah, it broke up. Can you repeat the question?
Yeah, sure, certainly. What level of integration in ExtJS will you be providing?
So as I was mentioning, there is one level is basically treating these D3 visualization as a component itself, tightly integrating it to the data package that is a part of ExtJS framework, so that you as a developer don't have to worry about how you would connect the data to the really cool visualizations that D3 offers. So that was basically demonstrated in the tree example that I was showing. And the other is providing means for you to bring in any D3 visualization and render it on the ExtJS canvas. So you would be able to bring in things that are not sort of componentized into ExtJS and yet work with it.
All right. I've got two questions that I think I could merge into one here. When can we expect D3 to be tightly coupled with ExtJS as a turnkey solution via the adapter? And then the second question is advanced access to the beta of D3 integration available to webinar attendees?
Yes, absolutely. So we will be doing an early access / beta program towards the end of this month, and we'll invite everyone in this webinar as well as through our forums through private access. So stay tuned on that. I think that answered the first questions as well, because essentially we're targeting that this D3 integration is done and made available to our customers by end of this month as an early access.
Okay. Which approach would be best for producing a process control chart visualization? Using standard ExtJS or using a D3 integration?
That's a pretty good question. It's sort of a trick question as well. There are process control charts, and some of that is sort of in financial charts that is part of our Sencha charts package that you could use. But if you were to create something really custom and not something that is basic, then I would say you go for D3. But if you're looking for a process control chart that is pretty standard, we already have one or two that you can find in our charting package.
Okay. The next question is, will the D3 ExtJS integration adapter eventually be available in the GPL version of ExtJS?
So at this point, we are targeting to include D3 adapter into our ExtJS premium package. I don't know if I can say that eventually it will be available, but our primary goal is to make sure it's working well with our premium package, and post that integration, we'll see if we can make it as a part of the GPL package.
Okay. Which D3 visualizations will be supported?
So most of the ones that I shared and a few more is what we are targeting. And one of the reasons I want to take a step back and telling our viewers why we are targeting that is D3, as open as it is, it's sort of boundless. So what we're trying to do is pick up the visualizations that make more contextual sense from an enterprise data perspective and pick those layouts and those algorithms to integrate with them. So obviously a tree and a heat map makes a lot of sense, and that's what we're trying doing as well. Parallel coordinates is another one that makes a lot of sense. Then we have Chord and some of the other ones that you saw that makes total sense because of the kind of data our customers have. Now, we've also seen D3 visualizations like, some particles which you don't really associate any data with. So we're going to not focus on that in the first phase. And if we see our customers wanting to get in that direction, we'll definitely incorporate if we receive that feedback from our customers. But essentially focus on things that can be tied to enterprise data in an easy way.
Okay. Our next question here is, version 4.0 of D3 is being worked upon. Are you supporting version 4.0 with this adapter?
So we started this work a while ago, and the version 4.0 was sort of just starting. So we are tracking on that branch, but when it comes out at that point, it will not support version 4 because version 4 is still not out there. It's just in the works. But we do plan to support it eventually when it is out there.
Okay, it looks like this is the final question. If anybody has any more questions, please get them in now. But I believe our final question is, what package will the D3 adapter be included with? I believe you've already answered.
So the D3, yeah, I already answered. It will be a part of the ExtJS premium package.
All right. That seems to be the end of our questions here, Gautam.
All right, thank you so much.
Thank you for taking the time, everyone. Thank you for joining us for this webinar. And from everyone here at SD Times and from Gautam and the whole gang in the webinar team, thank you for joining us.